4.9 quadratic systems. Just like with the other systems of equations, we had three possible outcomes, and we'll have that same situation with these. And then there's two different ways mainly to solve it. There's actually three, but you will only probably use only two. I'll show you. All right. And the reason why I say that is because the other one is kind of cumbersome. All right, so the quadratic systems can have two solutions, one solution, or no solution, just like the linear systems. Two solutions meaning it crosses at two places, one solution meaning it only crosses once, or no solution when they don't cross at all. Now we're talking about two different scenarios, one where you have a linear and a quadratic system, where one is just a line and one of them has the x squared term and one is just the linear term. So one's a line and one's a parabola. Okay, and that's what we've got with these three pictures. And notice how we have this parabola and this line, and it intersects right there at this point. Whoops, and right there at this point. Now those two intersections are your solutions. So you just tell me how to get to that point. So that would be 2, 1, which is 2, 1 right here. And then this one is at -1, go down, -2. So this one had two solutions because there were two intersections, and those solutions were 2, 1, and -1, -2. Remember, your solutions will be in the form of an ordered pair. Okay? Because you have to tell the location of those points. All right, now this one is a parabola and a line, and they only intersect right here. This one point, and that one point location is at 1, 6. Okay, so that is the solution to that equation. That's that system of equations, just 1, 6. So that would be when you plug in x is 1 and y is 6, that's the only one that will work on this particular one. And then you have this scenario over here where you have a line and you have your parabola and they never touch. If they never touch, that's no solution. Okay? Just like we had before. That was for a quadratic and linear system. And now we're going to have where we have quadratic, quadratic, where you have two parabolas. Okay? That can happen. You'll probably see these more than you will the other ones on any standardized test. This one, change color, intersects right here and intersects right here. Now, I'm talking about where the two parabolas intersect, not where they cross the axis. That's not the solutions to this system, okay? A lot of people will say that it crosses there, 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 there. No. This is a system of equations, which is where the two equations or functions cross. So that would be right here and right here. And those two solutions are -2, 1 and 0, -1. Okay? And they are ordered pairs. Right here, the blue parabola and the red parabola only intersect right here. So therefore, it would only have one solution, and that point would be -2, 0. Okay? And then this one, the purple parabola is over here, and the red one's over here, and they're never going to touch, ever. That would be a no solution. Okay, now you can have some, crazy looking parabolas crossing and doing all sorts of weird things. But there'll be either two solutions, one solution, or no solution. For the most part, I think that's all you would have. Don't think they would have any with more. Ways to solve, and this is what I was saying before. You have really three ways of solving, but mostly you're going to be using the graphing and get a different color. The graphing and the substitution only. Elimination's a little bit more picky, and that would mean that you'd have to know pretty much that it only had one solution for it to really be efficient to use. You can use those three ways, but most of the time it'll be graphing or substitution. Alright, so let's see what they look like. Alright, so for example, let's do this one by graphing. And I'm going to show you with the graphing calculator because I think it's easier for you to understand. what's going on and show you how to use this feature on your calculator. Alright, so both of these happen to be solved for y. Anytime you have things solved for y, you should grab your calculator and plug them in because that's already set up for you. X squared minus x minus 2. And the next equation is negative x squared. Use the negative button and not the subtraction button when you're doing that. Minus x plus 6. Otherwise, you're going to get an error. All right, so then I'm going to graph this. Okay, and it should have two parabolas that intersect. Or not. We'll have to wait and see what it does. Yeah, they do intersect. They intersect right here and right here. All right, so if I want to know what those solutions are, if I can't easily tell, you want to go to second, trace, and you want the intersection, 5. And you put the little spider guy, mouse person, I don't know what you want to call it, but you put the little thing near the intersection and hit enter, enter, enter. And it should tell you this particular intersection right here is at -2, 4. Okay? So -2, 4, which I've got that here. All right, and then I need to do it again to get that intersection. So I'm going to go to do second trace. Again, I want the intersection. And I'm going to put the spider guy over near that intersection. Okay? And I'm going to hit enter, enter, enter. And it's going to tell me my intersection's at 2, 0, which is what I've got here. So anytime they are in y equals, you can graph these and see exactly what the intersections are by doing the second trace calculations for your intersections. And it's really, really easy substitution, but I want to show you both just in case you need to know. Okay, so I'm going to move the calculator out of the way. All right, now for substitution, you have y equals something and then another y equals something. Well, remember with substitution, you have one of them solved for y. Well, we have them both. So this is saying that both are y equals, right? So I can take and write that like this. I could say negative, whoa, let's clean that up. That did not look good. That's not good to start with. Right, let's try it again. I'm going to write it up here. Negative 3x plus 4, that's y, right? So I'm just going to take this and I'm going to put it right here for y is equal to x squared plus 3x plus 9. All right, and then what I want to do is get this all moved over to one side or the other. I suggest moving everything towards your positive x squared term so that it remains positive. All right, so I'm going to add 3x and I'm going to subtract 4. So I'm going to add 3x and I'm going to subtract 4. That'll give me 0 over here. That'll give me x squared and 6x. And that's going to be 5. All right. From here, you can factor it if you know how to factor, or which would be very easy to do. So let's think of factors of 5 that add to be 6. What are factors of 5 that add to be 6? 5 and 1. And it's all addition, so it's going to look like x plus 5, x plus 1. All right? That equals 0. And remember, we needed to find solutions, so we have to find what both of these are. So I'm going to go over here and I'm going to say x plus 5 equals 0. So x is what? Which is always the opposite of what's inside, negative 5. X plus 1 equals 0. So that's going to be the opposite of what's inside, which is going to be negative 1. Now, we have two x values. You have to take both of them and plug them in. And I suggest plugging them into this one because it's shorter to see what your y values are. Because these are ordered pairs. These are solutions to this system, and it takes an x and a y value. So I'm going to take this first one. I'm going to say y is equal to negative 3. And I'm going to take my first one, which was negative 5, plus 4. Negative 3 times a negative 5 is 15. 15 plus 4 is 19. So that would be y is 19. So that means that that ordered pair is negative 5, 19. All right, the next one I'm going to plug in is y is equal to negative 3, and I'm going to plug in this negative 1 plus 4. So that's negative 3 times the negative 1 is positive 3. 3 plus 4 is 7. So that's y is 7. So that makes that ordered pair negative 1, 7. Okay? So you can see that you can do it either way, by graphing or substitution, whichever way you feel is the best way, unless it specifically tells you to do a certain way. If you solve them for y, then you can easily put them in the calc. If you took this in your calculator, you would see the intersection would be here and here. Okay? So it's not the difficult way to do it. Either way, it just takes a little bit more time. This one I personally would have put in my calculator and graphed it, because both of these are already set up for y equals. Okay? Alright, and then the last one is by elimination. And you'll see what I mean by this. Is not the one that most people will use. I don't recommend it. Because I need to get rid of this squared term if I possibly can get rid of it. Alright, so it's both of them are positive, and both of them have a coefficient of 3. I can multiply top or the bottom, doesn't matter, by a negative 1 and get rid of them. So if I do that, I'm going to multiply by negative 1 to the whole thing, which is y is equal to 3x squared minus x plus 1, which makes this become negative y, because you got to get rid of the y also. You have to find a way to get rid of a y and an x squared term. So you see it's not as easy to pick out. So this is going to be a negative y equals negative 3x squared plus x minus 1. And then I just rewrite this one because I didn't do anything with it. That's going to be y is equal to 3x squared plus x minus 1. Now I can draw my line and add vertically, which gets rid of my y's, and gets rid of my square terms, and gives me x plus x, which is 2x minus 1 minus 1 is minus 2. And that's equal to 0 because it's all gone away on that side. Now you're solving for x. So now that's going to be moving this negative 2 over. It's going to be a positive 2, which makes x 1. Again, you have your x, now you have to plug it in to get your y value. So I'm going to plug it into the bottom one. Alright, so that's going to be 3, 1 squared plus 1 minus 1. Right? So 3 times 1 squared, which is 1. 3 times 1 is 3. Plus 1 minus 1. So that's going to be y is 3. Okay, so my ordered pair would then be 1, 3. Again, if I see y is equal, and I have these things, I just use the calculator and plug it in and check my intersections. But if you had to, you could do it this way. Elimination is the last way I would do any of these. I would use graphing first always, and then substitution secondly, and never elimination, because it's what happens if you ended up with like 2x's, and you got to plug it in again. So it's a lot of work when it's easy to do the other ways. So we'll practice these, and the main thing is to be able to notice the locations of the solutions, or the x-intercepts, or the roots from a graph, and be able to find it algebraically also, but mainly they're going to give you graphs. So we'll practice this in class also, and come see me if you have any questions at all.